Hello and welcome to the next talk in the 2021 series of the Open UK Future Leaders training sessions. Please note this meeting is being recorded and will be made available soon afterwards on our YouTube channel. First, a little about the Open UK Future Leaders Group. The Future Leaders Group is a collection of individuals who are interested in open technologies, including open source software, open hardware, and open data. It includes a wide range of people that work in technology, intellectual property, outsourcing, procurement, data, coding and innovation, as well as private practice lawyers and in-house counsel that work in the technology sector and related fields. It operates under the direction of the Open UK Legal and Policy Committee and has a clear purpose to bring together and develop future leaders in legal and policy matters relating to open technology and to support and further the mission of the Legal and Policy Committee. The Future Leaders Group is currently co-chaired by me, Rob Grinnells, and I'm from Phil Fisher, and Katie Gibson from Bristow's, and we're both lawyers advising on technology and commercial matters. The group is always open to new ideas and to new members, whether getting involved in all of our activities or just dipping in and out of our various projects, so please do get in contact if you'd like to get involved. And for today's session, we're pleased to be joined by Dr. Ebrahim Bushehri, who is the founder of Myriad RF and CEO and founder of Lime Microsystems. Myriad RF is a family of open source hardware projects providing design for low cost and fully configurable RF boards, and Lime Microsystems is a fabless semiconductor company that develops RF and analog mixed signal solutions. Ibrahim's experience spans more than 20 years in directing and managing design teams for the implementation of high-performance integrated circuits within the wireless communications market. Previously, Ebrahim was with Middlesex University Microelectronics Centre, collaborating with organisations such as Nokia, QinetiQ, which was formerly the Defence Evaluation and Research Agency, and the Fraunhofer IAF. Ebrahim was a professional group committee member of the Institution of Electrical Engineers and is a member of the Institute of Electrical and Electronics Engineers. Now, we'll have a chance for any questions at the end, so please pop them in the chat, and we'll invite you on to voice and video to ask them yourself if you'd like to. Ebrahim, welcome to our session today, and thank you for joining us. And over to you to talk about opening up radio access networks with commodity hardware.
Thank you, Rob, for the introduction. Let me share my screen and I hope you see my screen here.
Yes, that's come through.
Excellent. As Rob mentioned, the title of my presentation is about opening up the radio access networks through significant usage of commodity hardware. Before I start my presentation, let me just give you a bit of background and highlight on what is really happening in the telco infrastructure, in particular in relation to the radio access network, i.e. RAN technology. Over the past 15 years or so, there has been a huge consolidation in the market, in the kind of vendor ecosystem that are supplying this type of equipment to the operators. To the extent that if you look across Europe, literally over 80% of what gets deployed in our networks is supplied by 3 vendors, 2 of which are really dominating the market. So if this trend is to continue, in the next 10 years or so, we can predict that over 90% of our network is going to be dominated by the equipment supplied by 2 vendors only. In my view, this is not a good situation to be in. Really, you have to question the very democratic nature of our society if 90% of the data that we consume or we share, or indeed any phone calls we make, goes through the equipment provided by 2 vendors only. So really, where we are today, in my view, is a very exciting turning point because there is also a political will to change this landscape and create diversity of suppliers out there that prevents that kind of eventuality. So having that in the back of our mind, what the industry is trying to do is to open up the radio access networks and bring as many suppliers as possible into this market. And our aim and objective is to introduce commodity hardware into this to accelerate that pace of innovation. So with that background, my presentation really covers 3 key items. Let me see, there seems to be a delay in me being able to go to the next slide. Okay, that's better. So I would like to start off with giving a short background to Lime, but more importantly, give a short review of where we are today in the telco world, especially in comparison to what has happened in the world of computing. There are a lot of lessons that we can learn from the democratization of computer networks that can be brought into the world of telco. And we really do believe that we are coming up to a major telco disruption, as I mentioned, not only from a technology point of view, but also the political landscape is such that everybody wants to see this happening. And we believe the combination of commodity hardware and software-defined radio will be the driving force. I want to spend a few minutes on that kind of concept. And once we have the basic chipsets and the basic components manufactured and provided to the market in that way, we need a platform. And for some years now, Vodafone and various other leading operators are driving the concept of what is called CrowdCell. I would like to spend a few slides describing that, why we think that could be a game changer in terms of enabling Open RAN and commoditizing the radio access network technology. Obviously, the developer community and the people behind the open source initiatives have made significant impact in the world of computing. So those needs to be brought in to this world of telco in order to accelerate that disruption that we expect to see in this market. And obviously, the third point I would like to cover, this should bring new suppliers and new ecosystem of open source initiatives that we think could really improve the networks going forward, especially so in the world of cellular domain. And I'll finish off with some concluding remarks. So this is really the structure of what I'd like to present today. And if I go to the next slide, just a really quick background for those who have not come across Lime. Our company has been founded since 2005, and we started with a single mission of bringing software-defined radio, a key non-programmable element in the radio access networks, and make it generally available to anybody and everybody to really accelerate the pace of innovation as far as radio technology is concerned. We are based in the UK, but we have offices dotted around various parts of Europe. So let us take a review of what has been happening in the world of telco, and what I'd like to do to start off with what is happening or what has happened in the world of computing, and try and make a comparison between the two and see how the world of telco could progress in the future to be able to innovate in much in the same way as has been done in the world of computing. So if you look at how computers have evolved since the 1970s, we were really reliant on supercomputers. These are really very power-hungry, large structures that were essentially not accessible to many people, very much using specialized hardware, and could only be programmed by a selected few. It was during the 1990s that personal computers came into the scene and enabled a much wider community of people to be able to program these and innovate around the world of computing. And through the years up until now, we've come to a point that a significant level of computation power is offered in a very small footprint. I don't know the age profile of the people on this call, but I used to program those mainframes using punch cards when I started my career, and I'm literally wearing the same mainframes on my wrist today. So this is the pace of progress that we've seen in the world of computing. So let's compare that to what we've seen in the world of telco. Back in 1980s, macro base stations, really these large structures, just in the same way as supercomputers and mainframe computers came about in the world of telco, enabled a very wide coverage and enabled essentially mobile communication as we see it today. It is important to note that even today, our telco infrastructure is very much reliant on these macro base stations. They are the backbone of the wireless infrastructure that gets deployed today everywhere. And although we've gone to deploy smaller footprints, smaller base stations or radio access networks in the form of micro and pico base stations, but these are really deployed to extend the coverage of macro and indeed maintain the data rate, for example, when it comes to 4G. There has been some deployment of femtocells and small cells that could appear in the corner of an office or in people's homes, but that largely hasn't happened due to various reasons, one being that these are really closed systems managed by very few service providers, and the complexities around this type of deployments has meant that there has not been much of these type of platforms deployed in the field today. So let us use this as a basis of understanding how we can accelerate the pace of innovation in the world of telco, much in the same way as it has happened in the world of computing. If you look at how, for example, the telco has progressed over the past 40 years or so, we find that to go from one generation to the next, we take almost 10 years. To go, for example, from 2G to 3G took 10 years of effort by the operators, creating network infrastructure that could provide reasonable coverage. And through the years, we went through higher and higher data rates, achieving better performance, both in terms of throughput and latency, to the point that 4G really demonstrated the potential of wireless connectivity as far as high data rate and coverage was concerned. This is in comparison to the world of computing that every 2 years we've been able to double the performance, to create a situation where innovation could happen from anywhere. Anybody could come and contribute towards the computer networks and make it more secure, higher performance, and really apply and provide myriad of services that our computers can offer. This has really not been the case in the world of telco. And with 5G happening, with all the services that are promised around 5G, from a technology point of view, the disruption is happening, but certainly we cannot afford to spend another 10 years maturing the 5G technology. And given the promises behind 5G, certainly we feel, and some of us in the industry feels that we need to take experience from the world of computing and make sure that this is very well and truly embedded into the 5G networks that's going to be deployed in the future. What I'd like to do is to highlight at least one key example now in the world of computing that demonstrated the power of access to technology alongside open source initiatives that really created a quantum leap in terms of deployment of devices in the world of computing. I think when ARM appeared in early 90s and made the technology or the RISC processor available in the form of an IP that anybody could utilize in their designs, it actually created a ecosystem whereby today we know there has been over 100 billion devices that use this processor. And indeed, it then led to massive deployment of Linux, for example, or Android, these open source operating systems that today have gained huge amounts of momentum. Round about the same time, Linux came about, and it was in the late 90s that IBM came along and essentially contributed a significant amount of effort towards the Linux code, and the rest is history. So it is this kind of example that we need to use and learn from if you are going to accelerate the pace of innovation and bring diversity into our ecosystem in terms of supply to the telco infrastructure. So with this background in mind, let me focus on where I think disruption is going to happen in the world of telco. And as I said, what is exciting is that for the first time, we see a political will to change this ecosystem and bring many more players into this game. So let's look at what 5G is actually promising. We are talking about hyper connectivity. We are talking about connecting people, buildings, connecting things as part of an IoT rollout everywhere, connected cars. So this means that there is going to be a significant level of technology needed for this to happen. It will take many years for this thing to mature. Certainly, the industry could be accused of over-promising, but from a technology point of view, such hyper-connected world is certainly going to be made possible. Given the progress we've made in the past, and if we remain on course, then we believe 5G, and certainly when we get onto 6G, this hyper-connectivity could be a reality. And the ambition the industry has set for itself is really significant. In this context, we are talking about increasing the capacity by 1,000 times, connecting everybody on this planet, the 7 billion population that we have. It's a tall order, but one that is doable if we accelerate the pace of innovation and get a lot more engineers, software developers around the technology than we have today. And alongside that, there's a projection of over 7 trillion devices in the context of IoT that is going to get connected in the future. And all this connectivity, all this throughput needs to be catered for with less energy consumption. And if you're going to enable applications that require very low latency, such as healthcare, surgeons operating on patients remotely, we need very low latency and very high throughput at the same time. So there are a lot of conflicting requirements. There are a lot of technology that needs to be put together in order to enable this. So the challenge is huge, and we believe certainly we require a significant number of players to come on board and diversify our telco. As it happens, the industry itself has recognized this need, and as of some 4 years ago, there has been quite a few industry initiatives that are driving the plan in such a way to bring off-the-shelf components, generally available products that could be put together in a short space of time, but more importantly, the idea is to disaggregate hardware from software. So in that sense, you have a hardware just in the same way as we have in our computers that could be customized by software, so that the developer community, those who develop software, could then work on a common hardware platform and again accelerate the number of services and software packages that could be offered as part of the mix. This incidentally drives the and would increase the security by this ruthless drive towards network transparency. We know what hardware we are using. Much of the software could potentially be using open source, just we have it in the way we have it in Linux and Androids, for example. And indeed, an open ecosystem of developers and suppliers can come on board and improve the pace of innovation. This incidentally will accelerate the operational readiness and commercialization of these products. They are going to be largely app-enabled, as we have it in our mobile phones and in our computers. And basically, as I mentioned, the initiatives that are in play is bringing the industry together along the same sides of a sort of thinking. And one of them, which has gathered a lot of momentum, is ORAN. I believe most of us have heard of it. This alliance is essentially driving to take the industry from what it is today in terms of proprietary hardware to things that are software defined. Get rid of these closed interfaces between different components that exist in the radio access in particular, and making them open. So anybody who has a product in each section of these type of platforms could come along and introduce their products or their innovation into the system and improve the overall performance of what we deploy out there. You know, all these predefined functionalities that is under the control of very few vendors are going to be taken out of our system based on such kind of initiatives, making them more programmable and flexible. And obviously, the whole intention is to get away from this single vendor type of supply that takes care of everything from components to platforms to the equipment, all the way to software and services, and bring a really multi-vendor friendly type of ecosystem into the mix. It should be highlighted though that Open RAN is not equivalent to open source, neither in terms of hardware nor in terms of software. Having said that, we believe this is an excellent start to bring open source in the mix and making sure that open source plays a significant role in the way that future networks will be deployed. So on that basis, I want to spend a few slides talking about introduction of commodity hardware into a very important element in our infrastructure, i.e. the RAN technology. And this is significant and is in line with the policies that are being put forward as well as how industry wants to move in the future. So this is probably the only technical slide that I would like to present, but hopefully I'm able to present it in such a way that everybody on this call can grasp the basic ideas. When you talk about the RAN technology, there are two key elements within it. There is a digital processing that processes all the signals that we receive and send through our radio access. And there is another aspect of it, which is the RF component side of it, radio frequency components. These are very high frequency electronic circuits that are responsible for transmitting and receiving the signals. And these are traditionally have never been programmable. They are single function type of circuitry. So as we went from 2G to 3G, literally we had to replace all the components around the RF. And as it turns out, much of the digital technology was also application specific. So a whole new set of equipment had to be deployed in order to go from 2G to 3G. And the problem with the digital is far less, in the sense that over the years, the industry has been moving more towards programmable chipsets in digital domain because it's so much easier to do so. And it has advantages for the current vendors. They can upgrade their equipment much faster and indeed charge more at the end of the day for added applications that yet they can run on these type of digital solutions. What is happening though, the drive towards commodity hardware is already there, using GPPs, the likes of Intel processors, ARM, AMD, GPUs, for example, what NVIDIA produces in mass and are generally available. Anybody and everybody could place an order and obtain a motherboard. Everybody and anybody can actually obtain a GPU. So it means general purpose processors and GPUs, should they be utilized in the core of our RAN solution, it means that we are essentially democratizing our RAN. The problem, of course, in addition to this digital circuitry, we need these RF components that I mentioned earlier on, and those needs to be software programmable and generally available much in the same way. The good news is that over the years, software-defined radio has also progressed in a significant way. If you look at the early deployments of software-defined radio, we are looking at really heavy boxes with lots of electronics, much in the same way as we had in the world of computing around the mainframes. But certainly over the past decade or so, given the number of air interfaces that we need to cater for these days, all these wireless connectivity ranging from Wi-Fi to Bluetooth to DVB, ultimately to all the IoT devices that need to be connected, alongside the cellular that we are talking about, going from 2G to 5G with myriad of bandwidths and standards that we need to cater for. Software-defined radio technology has also come a long way, to the extent that today we have at least over a dozen suppliers out there that provide software-defined radio that is generally available. In some cases, you plug them into your standard laptops and desktops, and you load a bunch of software, and you have a highly flexible radio that can tune to any frequency and practically any bandwidth. This is a game changer in our view and helps this telco disruption that is waiting in the wings. Because Now, certainly one of the suppliers of these is through Myriad RF, the initiative that we've launched together with Lime Micro. You are able to get hold of these platforms that plug into your laptops via PCIe cards, for example, and the entirety of the solution could be created out of fully commoditized hardware. It is important to note that these boards that you see on this slide are completely open sourced. The database for these type of boards are available on GitHub. Anybody can pick it up and essentially modify them to their needs, manufacture them, and supply them as they wish. So it was important to take those first steps to open up these RF components, the software-defined radio, so that they can sit nicely alongside general purpose processors, generally available motherboards, and provide a total solution. We've obviously gone further. The software, the drivers, the APIs that enables these radio solutions to work are also open sourced, alongside some very advanced algorithms that you would typically want to see in your RAN technology, digital pre-distortion, to name a few, again, are available and could be, anybody could download, improve them, and indeed customize it for their needs. So it is important to emphasize that the technology side of things are already happening and reaching a excellent level of maturity, and certainly I do see a fairly reasonable deployment of such solutions going forward in the next few years. Since this is an Open UK event, I just wanted to highlight that UK could play a very important role in the supply of these RF components, given the efforts of companies such as Dialog Semiconductor, ourselves as Lime. We have manufacturing capability here in the UK in the form of Newport Wafer Fab, providing the gallium nitride devices that are so central to the deployment of 5G. And obviously Canonical, who provides the open source operating system that is so central to the deployment of such solutions that are software defined and programmable by a large community of people out there. So this is, as a side note, I think UK could lead some of these activities going forward. So having got all these components, all these platforms that could be put together by a large and diverse set of suppliers, ultimately, we need a platform, just in the same way as we had desktops and laptops in those early days of computing. We need Open RAN. We need designs and implementations that can be easily obtained by anybody and everybody and be programmed. So there was an initiative came about as a result of the efforts that Facebook put together in the form of a Telecom infrastructure project, which was launched, I think, back in 2016. And as part of that, there's an initiative called the Open CrowdCell, led by Vodafone, in fact. It is a complete network in a box that can also provide an extension to the macro and improve capacity and all manners of things that would be, in our view, so central to the deployment of 5G and beyond. Obviously, such a platform should also be fully programmable and fully customizable and generally available to everybody. And that's the kind of mission of this Open RAN CrowdCell type of initiative within the telecom infrastructure project that Facebook has launched. So I truly believe, much in the same way as we saw a significant uptake with what ARM did in early 90s, together with the contribution of IBM in Linux, we could be looking at a future where Open RAN and telecom infrastructure project of Facebook, led by the CrowdCell initiative that Vodafone has put in place, these combination could essentially achieve the same, provided that the hardware platform is supplied in the same manner as computers and laptops and mobile phones happened as a result of what ARM and Intel have done over the past 40 years or so. So with that in mind, let me just focus a little bit on what is inside this CrowdCell. It is highly modular. It consists of a backhaul connectivity, so you can connect this box via either wireless or Ethernet to wherever else you want to connect it to. Indeed, it could be to a core network of an operator. But the three other elements that is used within this is essentially at the core of it is a standard computer, standard motherboard that executes the entirety of the digital solution that we need in a RAN and beyond. In fact, you could incorporate the entirety of your core network here in this box. Followed by software-defined radio that, as I mentioned, is democratized and it's open source and generally available to anybody and everybody. Alongside a power amplifier module that gives you the range that you need in order to cover a decent range out of these type of boxes. So it means that essentially we have brought standard computers with highly accessible software-defined radio in the same box, and anybody and everybody could buy this, set up a network, and be up and running in a fraction of the time that it would take if you were to deploy a traditional equipment from one of the two key vendors that today are dominating the rollout of our market. So on that basis, in the same manner that we could scale the computation power or the performance of our computer network from my wristwatch all the way to a fully fledged server, enterprise server, we could do the same here. We could implement a macro base station or a wide area network coverage as depicted in the diagram or the picture I'm showing on the right-hand side of this as I'm pointing out to it. We could scale it all the way back to an enterprise solution on the left that Vodafone has been working on for some time, and have it placed in the corner of an office and essentially provide a complete cellular service in a given area. What we can do, essentially what computing has done very successfully, and add functionality to our radio access network that was not at all imaginable even as far back as a few years ago. In this platform, as I'm pointing out to it, we've added speakers, microphones, and turned the radio access network into a multimedia platform that provides improved connectivity, very high throughput for actually transferring media from one network to another network in a very low latency and a high throughput manner. So effectively, we can speed up the deployment, the construction of our radio access networks to match what we've been achieving in the world of computing should the industry move towards this highly commoditized platform that we've been talking about here. And in fact, the whole industry is behind it, and we think this is the way the future is going to pan out for our network infrastructure going forward. So if we assume that the platforms and indeed the infrastructure and the hardware is getting mature to the extent that it can become available in that manner, we have to emphasize the work of the developer community and bringing applications to these type of networks, because after all, every application that is being developed in the world of computing can be cross-migrated into our telco. So in that manner, we have to acknowledge the work of Canonical, Ubuntu, that provides the very operating system that is used in these CrowdCells, alongside the effort of putting together app stores that could accommodate applications that runs on the network side, but much in the same way as you could download your applications on your mobile phones or on your computer today. This is a paradigm shift in the sense that 4G could be classified as an app. You obtain a piece of hardware, you download your 4G stack, and indeed you may download your 4G core, and essentially turn that hardware into a fully fledged 4G network. Alongside this, higher level applications can sit on top, and we could be looking at very varied type of services that can be provided for such networks, really fulfilling the promise of 5G and beyond, which is a lot more service oriented, a lot more about connectivity and democratizing the wireless networks. These are obviously a very limited list of applications that a few developers or indeed organizations have been working on. What I'd like to emphasize here is the variety of the application. From one end of the spectrum, which is far more related to the actual air interface, to customizing the hardware to provide 2G or 4G coverage, all the way to the other end of the spectrum of installing things like augmented reality and virtual reality directly onto our RAN technology, so that we can provide very low latency, very high throughput rates that was not traditionally possible in our network. So having said that, I think the combination of the commodity hardware and the availability of the applications, we will widen the use cases and the services that our network can provide in a manner that is very high performing, achieves the quality of the service that is required, and brings a diversity into this ecosystem that has not been achievable up to now. So the last but very important element in all this is the role of new suppliers. We need to create an ecosystem of suppliers that could get around these type of platforms, around Open RAN, around variations of it, such as the CrowdCell, so that basically we can accelerate the pace of innovation, as I keep referring back to. And from my perspective, open source ecosystem plays a huge role in this endeavor. I cannot underplay, in my view, the contribution that open source can make in this area. So already, if we take CrowdCell as in isolation, there is a significant level of contribution from these organizations that I've listed here, either consciously or unconsciously. Let me just focus on 5 pillars of essentially elements that is required to deploy these type of networks. At the very bottom of the food chain are the manufacturers, the people who manufacture our silicon, the people who manufacture the very solutions, the actual boxes that gets deployed. And going up are the people that design and implement those microchip solutions. If you are going to democratize the wireless infrastructure, we need to rely on generally available chipsets from Intel, AMD, NVIDIA, and people like Xilinx. Now, all of the chipsets that are provided here are already utilized in the CrowdCell platform that I mentioned earlier on. Bring on board radio technologies. Obviously, I mentioned dialogue as part of the mix in terms of the CrowdCell contribution, but there are many more that are actually already collaborating and providing input to the Open RAN initiatives. Software and applications becomes another key important factor. And right at the top are the service assurance, orchestration, maintenance of these boxes out in the field, and distribution through large distribution channels that can provide these type of networks at mass and to wherever that is required in the world today. Obviously, all of these are driven by tier 1 operators that have got the scale and the ability to make it happen, and the likes of Vodafone that are driving this CrowdCell initiative, EE that came along and contributed to the open SDR type of platforms. And it's interesting for me also to see European Space Agency that have been sponsors of software-defined radio to a large extent. They are not traditionally a telco operator, but they have significant amount of technology that they can bring to bear in order to accelerate the coverage as well as the kind of data rates that we inspire for. So just to highlight the open source initiatives, obviously we are highly focused around this, and we believe UK in particular can play an important role given our heritage and our focus around open source. We found that since the launch of this Myriad RF around software-defined radio, since 2018, we've been able to double the number of people, the contributors towards this, to the extent that by the end of 2020, we had about 15,000 developers signed up to this initiative. And we believe this will grow in time, and a significant number of those could be contributors towards the ultimate goal of open sourcing the entirety of our RAN technology going forward. So just to really highlight the fact that this is not an isolated effort. When it comes to the core network, when it comes to other elements of our infrastructure, there are a variety of open source initiatives that have been running in the background, some in stealth mode that are now becoming apparent to the larger community out there. And our initiative, or what Vodafone has been driving for some years, will hugely benefit from these other initiatives that can contribute towards the same aim and objective of opening up the RAN, virtualizing it, and making sure that enables everybody to contribute and diversify our ecosystem. So as a way of conclusion, Obviously, the ultimate goal is to democratize the wireless innovation. All those promises that 5G is making, and indeed much of that should be realized as we go from 5G to 6G and beyond. We need to open up the infrastructure, whether it's the RAN technology, whether it's the core, the entirety of the telecom infrastructure needs to be opened up. And the Open RAN initiatives is an excellent start to this road ahead of us. And it's no longer the question of if, it's the question of when and how this could be accelerated. The way to accelerate this is to use what we have utilized in the world of computing and bring that world into the world of telco and bring all those ecosystems, all those hundreds of thousands of people who can program a Linux box into our network and enable them to bring their expertise and their innovation into our infrastructure. And I believe these open source initiatives, backed by the silicon vendors, is going to be the key driver in enabling a future where Open RAN becomes a reality and goes from this 1% deployment that we are seeing today to having the majority of the network based on that principle going forward. So this is pretty much sums up what I wanted to share with you today. I hope that has given you some insight as to what the industry is doing and what the ultimate goal of Open RAN technology could bring to us all. Thank you.
Thank you, Ebrahim. That was really brilliant and very interesting. I think we've got some time for some questions. I can see in the chat box. Amanda, do you want to come on video and ask you a couple of questions first?
I was thinking about what you said about Canonical and Ubuntu. I don't know whether you know, and certainly people listening to this won't, 10% of my life has been dedicated to Ubuntu. I've worked that out. And, you know, I lived, slept and breathed it for 5 years. The difficulty that Ubuntu, like many other parts of the open ecosystem has, is where the revenue is generated from all of these models. And I wonder, Ebrahim, if you've got any thoughts on how we make sure that the component parts generate revenue out of this infrastructure so that they can go forward successfully and keep supporting that.
That's an excellent question, actually, and that has been the subject of discussion with a number of suppliers when we go into this model. How are we going to monetize all of this? Let me focus on Ubuntu because I feel that they could play a very important part in this whole thing. Obviously, their operating system is used in this type of CrowdCell Open RAN type of offering that we are talking about. But really, the revenue is going to come from software and services. In that mix, I'm talking about applications. So one of the things that we are doing is creating this so-called app store. These could be private and public app stores. And if a service provider wants to utilize these apps, evaluate them, or indeed do trials and eventual deployments using them, those applications don't have to be open source. And there could be a dollar value associated to those, and especially so when it comes to support. Even if they are open source, there has to be some level of payment towards the services that is going to be provided by those who are actually providing those applications. So people like Canonical and the app developer community could be hugely benefiting from all of this, because any operator, any service provider, whether it's private network or public network, are going to need the support of those developers. And indeed, they would need the support of people like Canonical in order to ensure that those networks are maintained and supported. So this is one way of monetizing. So for example, one idea is that those applications that appear on the Canonical App Store, there's a percentage of those sales are going to be going back to Canonical to improve this infrastructure around the App Store going forward, maintain it, and in fact expand on it. I hope I've answered your question. So open source doesn't mean free. It means that essentially you typically collapse the size of the market to something like 10% of what it is today. If it's really expensive, which I believe telco infrastructure is, and cannot continue on that path because it becomes totally unaffordable by many of the operators that I talk to. So it collapses that overall market and defines new players into that market that can monetize and take revenue from it. So I hope I've answered your question, Amanda, but certainly I do see a lot of opportunity for the likes of Canonical and whoever is signed up to the notion of Open RAN.
Yeah, you definitely did. Thank you.
Yeah, thank you. I think, Andrew, you've asked the next question. Do you want to ask it, or would you like me to? I don't mind.
No, I'm very happy to do that. Thank you, Robert. I'm getting a nasty echo, though. I don't know if... Is that still echoing? No. That's much better. Excellent, excellent. Ebrahim, thank you so much. That was really, really fascinating. And this is an area that I find really, really interesting. I mean, my background is that I'm a lawyer, but there was a point in my life just after I'd left school that I was sort of seriously thinking of becoming a silicon designer. And I actually applied to Edinburgh University to do their chip design course. But then rather than doing something useful like that, I decided to join the dark side and become a lawyer instead. But I've always sort of maintained an interest in the technology. I mean, what I'm really fascinated by really is FPGAs. I think you know, they have a remarkable opportunity to do all sorts of, you know, astonishing things. But one of the things I'm interested in, because I'm involved in a study that we're doing for the European Commission at the moment around open technologies, and that covers open source software and open source hardware as well. And what I'm particularly interested in is the sort of different characteristics that each of those has within a project. And you know, you're in sort of a really interesting position in that, you know, you've got the hardware, the circuit boards that are open sourced, then you've got the gateware, which is the configuration of the FPGAs, and then you've got the software itself, which sort of both covers firmware and also the applications that sit on top of that. And I mean, I've talked to Andrew back about this quite a lot as well. So hi, Andrew. I'd be interested to hear your insights on what the distinct communities are that sort of coalesce around those three different areas, and whether there is a distinction between them, whether they operate in different ways, and whether in fact they are distinct communities or not.
That's an excellent question. Actually, look at the current vendor situation. So you mentioned about the silicon technology, the hardware, the kind of low-level physical layer, the stuff that is so tightly coupled to the underlying hardware that we are talking about, although it being softer, as you mentioned quite rightly, the firmware that sits on top of FPGAs. And we go next level up, that these are the MAC layer, the software that essentially enables these boxes to perform as 4G or 5G. And then you've got these really high-level applications that could sit on top that has no essentially knowledge of the underlying technology that sits behind it. So the current vendors have had to build this all across the technology, from the silicon all the way to the services. And obviously these have to come together in a way that we can provide a total solution. So the disaggregation of hardware and software is not as easy as what I'm talking about. That's why the current dominant vendors have been so successful in capturing the market and keeping it to themselves. So what is happening in the world today, and what I believe is going to happen in this ecosystem, the Hardware, as far as silicon, no longer has to connect to anything else. We could make it totally agnostic to the rest of the system. So when it comes to IPs, when it comes to actual construction of these boxes, what we create is not going to be any different to your standard computers. So when you ship a radio access network, since it doesn't have a software, all the IPs, all the issues related to that basic hardware platform is going to be the same as what you have today when you're shipping a silicon to wherever it goes. The actual IP issues and things of that sort comes into play in terms of this middleware that creates the radio access networks and provides you with a 4G coverage. That's where we have a minefield of IP issues, and basically the industry has to come together to ensure that those IPs are secured around this notion of opening up the RAN. And what comes on top of that doesn't need to be even aware of what is below it. Literally, any application, it could be augmented reality application that today you run on your standard laptops, could appear there, and basically doesn't even have to connect to the rest of the system. So where we need to pay attention in terms of IPs, in terms of how we roll out Open RAN, is this interface between that very physical layer and the higher layer that defines the network to be 4G or 3G, or in this case, what we are looking at is 5G. So that's where the issues may arise, and we need to pay particular attention to that sector. The rest of the system is fully disaggregated and comes under the existing IPs that essentially has been taken care of, whether you do a computer network or you plan to roll out a network based on Raspberry Pi, for example, even. So I hope I've answered your question. I guess that's where you were kind of pointing out to.
Yeah, no, that's really interesting. Thank you.
And by the way, I'm really impressed by the depth of your knowledge as a lawyer. I think you're talking very, very well the engineering language, for sure.
Thank you.
Okay, unless there's any other questions. I haven't seen any more come up in the chat, but we have a second if you want to get one in there. Then if not, then thank you very much, Ebrahim. It's been fantastic having you on today, and it's been a great talk, and I'm really pleased that we've had some really good questions as well. Thank you to our people asking the questions as well. And just to say that our next talk next week, will be with Javier Serrano from CERN, and he'll be talking about open hardware at CERN. So please do join us for that one. And thank you, everybody. Cheers. Bye.